Hey everybody, it's time again for the SMC Journal podcast. This is the show where we talk about software engineering and everything that is involved with IT in some way, shape, or form. I am Scott Moore, your host, and I really appreciate you joining me today. Probably going to notice a few slight tweaks and changes to the show. Some of our graphics are going to change because we're doing some slight rebranding. And also, you'll notice that Agent 503 is missing. I think he's on a secret mission that we can't really talk about right now, but more about that later. We hope maybe before the end of this year of 2024, we will be relocating our podcast studio. And so we've already started making some of those preparations, and that's why you're seeing some of the changes. So today's show is about me introducing you to someone that I follow on LinkedIn all the time because he's always producing really good information, and also about the topic of eBPF, the extended Berkeley packet filter, and around the use case of using it to solve performance problems. I do see a lot of articles out there dealing with eBPF on a network or observability or security type issues, but not a lot around performance. But my friend, who I'm going to introduce you to, is actually working on a project right now. He's almost done with, and he's delved into this. He's going to share some of his insights of what he's learned. And he's somebody that you should probably be following. If you're following me, you should probably be following him because he's got about 8 or 10 posts a day that are really good, informative things around software engineering. So if you follow that, you're going to be very interested. So let's go ahead and talk to my friend, Donald Lutz. Hey, Donald, welcome to the SMC Journal podcast. It's great to have you on.
I really appreciate it. I follow your stuff and it's really interesting. I love the fact I can look at all the things you're doing on your profile.
Thank you. Well, I look at yours as well. And I'm glad to have you on the show. And it's good to actually get and talk with you because we're always communicating on LinkedIn primarily. And I noticed I was watching your profile today on LinkedIn, and you have over 21,000 followers as of today when we're doing this broadcast, including me. And I think that's because you are consistently putting out a lot of good links and information around, software engineering and systems engineering, those kind of things, the latest on Kubernetes and where the market is right now in IT. So I want to definitely make sure that I get a chance to recommend you to anybody who's following me. They should be following you as well. So I want to give you a chance to introduce yourself to my listeners and talk just about, who you are, what you do, and how you got involved with what you do now.
All right. Well, I started a long time ago. I worked in a research lab and I did a lot of system programming. So that's kind of my background. But over the years, I've done a bunch of startups, worked for different companies, and my whole interest has always been system programming, platform engineering, and distributed systems. So that's really what my focus has been. And I've always liked it, but I've always stood out because at heart, I'm an enterprise architect who likes doing platform things. That's what I really like doing. And I've discovered that there's a lot of people, who don't understand the platform stuff and don't understand software engineering.
That's
So my
right.
goal has been, how do I bring those two sides of the universe together? That's really what I'm trying to do.
You've been diving into the world of the extended Berkeley packet filter and working on some stuff like that. That was perked my ears up because last December, one of the experiments I did for the Performance Advisory Council, and we held a meeting in Orlando back then, right before Christmas. I dived into eBPF myself, and I was trying to create flame graphs, and I was focused on the use case around how do we use eBPF to solve some performance problems, and that's mostly what people are using it for is to create these flame graphs. And I actually created my own Kubernetes cluster and I was pulling information from it. But I got to say, my experience was less than rewarding. It's not that I didn't understand it. It's that even though I understand it, I'm not sure I liked it. So I'm hoping that you can kind of change my idea of it. Tell me about what you've been investigating with eBPF, what you've been working on with it, and what's going on with that.
Well, I can kind of explain how I got into it. Since I do a lot of Kubernetes custom controllers and operators, one of the problems when you start using service mesh, you have to introduce sidecars, and sidecars become difficult and kind of weird because you got these sidecar proxies. They have to talk to each other. Sometimes they don't initialize properly. You then have to add your YAML so you can get them included. And I found, I've done that for a while. I'm actually working on a book on Linkerd. But I get sort of sick of that complexity because I think it's not what I wanted. So I decided I should start doing eBPF. So I kind of read, a couple of books and I started doing it because I said I could write what I want. And I wanted to avoid the whole sidecar mess. And because most of my stuff lately is Kubernetes, it's ideal. If you have eBPF and you run it on a container or virtual machine, you can get everything because the kernel's right there. And
Right.
that's what really drove me because of that problem with the sidecars. And I've had a long debate with a lot of the linker D guys who are like, well, ours, we can do that better. I'm like, well, it's not better. It's just more complicated because sometimes when you init those containers, they don't come up in the order you want. So all of a sudden you don't have things working. So that was my real problem that I was concerned about because that's kind of one of the things I wanted to handle. And that's what drove me to eBPF.
Well, you mentioned complexity a couple of times, and that's the thing I ran into. Even using just getting started in eBPF, this is not something that just a casual IT person is going to just jump up and just start using, and without some deep diving, in my opinion, right? So I don't think eBPF was originally intended to necessarily solve all problems, like with Kubernetes performance specifically, because it came from stuff that was built before that. Can you talk about a little bit about the history of eBPF and what you've learned about like where it came from?
I can't, it really happened in 2014. They were really playing with Berkeley packet filter. Quite a few individuals, I won't name them. And they were, the problem is if you wanted to do stuff with the kernel, you had to write a kernel module. And writing a kernel module is complicated because have to get in a Linux distribution. Then you have to basically make sure it gets blessed. Then you have to have, Torvald say, oh, this is really cool. Then 5 years later, oh, it's not in the distribution I use. I can't use it because SUSE didn't develop. So that is really the evolution. And a couple gentlemen got together and they said, oh, we could make this extension that would allow you to write the eBPF code without having to, write a kernel module. And I wrote some kernel modules, but I don't think kernel modules are something the average developer is going to touch because it's way too complicated. And, that's the evolution fundamentally. And because it started happening, but I would claim in the past 3 years, it's kind of exploded because cloud native is exploding, Kubernetes is exploding. People are trying to build microservices. To me, that's what's drawn it out.
I agree, and I think Kubernetes has really been the amplifier because you need to get inside of there, right? And that's what eBPF allows you to do. You're coming from the inside out to get this information at the lowest level without providing a lot of overhead, right? And I think that's the beauty of it. But I think it is a little more complicated than just you're flipping a switch and everything's going to start working, right? So in terms of performance, what do you think the best use case is for using eBPF? Because I've had some interviews with other companies this past year about ground cover using eBPF for observability stuff and other use cases. What's your best use
The people
cases?
I've talked to them, and the use case I'm starting to think about is I want to be able to measure the performance of. I want to spin up, say, 100 microservices that are interconnected. They're a really complicated system, and I'd like to measure all the performance between all those systems. Also, I want to tie it into things like Jaeger and other things, and that's the performance I'm looking for, and that's what I'm working on right now. When I talk to my buddies who are really raw DevOps people, they're like, well, that's a really complicated use case. And I said, but a lot of the things I've built historically is that complicated use case, and if I do it, with the service mesh, I end up with like these 100 proxies that start multiplying, and then, I start losing network because the network, there's too many, it slows down. So I'm trying to, can I measure the performance of those microservices and understand the performance? And if I grow it to multiple clusters, can I measure the performance between those different clusters?
Yeah, and so if you got to solve a performance issue, you got to get the data and you got to get it pulled out somewhere, and you got to get it visualized. So when you pull this information out, where are you pushing it to, and what are you looking at that graphs it out that tells you where the bottleneck might be?
Well, I've been starting looking at it and putting it into Prometheus,
Okay.
as a first cut, but I don't love Prometheus. So I've been debating where do I want to put it? And that is my next evolution where, Prometheus is the standard that everyone uses. But, Prometheus is a single instance fundamentally. To, scale Prometheus is really painful.
Yeah,
It's
and
not
hard.
enjoyable and hard. So I've been trying to look at what else could I do. So I've been looking at, Loki and a few other things that might serve it better. I haven't answered that question, but that's, and I don't want to generate flame graphs because that, they're interesting, but they don't solve my issue because I have to look at it. I've been also thinking about, can I just shove it in the Kubernetes dashboard, build an adapter, shove it in there through kubectl, and get what I want.
Right. Do you think this is a use case where it's not just about historical data, although you'll need that historical data, and that's the problem with Prometheus is when you're talking about scaling is having all that historical stuff. It's really good to tell you what's going on in the last few minutes, but could this be one where you don't rely on this large database full of information to graph all the stuff, but maybe it's a real time streaming sort of thing that you look at?
Usually, as you just phrased that. So one of the thoughts
Yeah.
could I feed it into Kafka and you use the new Kafka sort of SQL management tools they have to get what I want because I just need to, oh, I need to this one up, this went down. So if I look at this, this is constantly linearly increasing. So that's what I need to know.
Have you found any major performance pains from the stuff that you've already been working on? And if so, I mean, can you talk about something where you had a win on this?
Let's see, a win. Uh, when I moved a couple things from Linkerd, the win was fundamentally the amount of networking performance traffic dropped significantly because I didn't have all those proxies going on. And that was the first win. I'm in a slow phase of trying to get this to happen. I would claim in the past 2 months is when I started chasing this down a lot more. And in the process, I reached out to a publisher and said, hey, you guys interested in eBPF and maybe using Go and trying to do some interesting things, whether it's observability performance? And they said yes. So that's kind of another thing that's driving my investigations.
Awesome. So, if we talk about eBPF in a broader sense, because I know there's like Cilium is working on a lot of stuff, and then there's more than just
Well,
performance going on, and there's conferences now around it. So, where do you think the biggest like focus is right now outside of performance? Is it security or is it network?
network, and I think it's software defined networks because you know Isovalent got bought by Cisco, and
Hmm.
Cisco's been working on you know software defined networks. I worked for a company years ago that we were trying to do software defined networks, and it's a hard problem. But if you have something like eBPF and you have what Isovalent has, Cisco could start billing that. I think that's the big area that everybody's chasing down because it makes it easier to build your networks. And I want to redefine this over here. Oh, let's change how we deal with the Ethernet. Let's make sure we change how these various IP4 map. I think that's where it's happening. Security is there, but I think the network is more important currently.
When I was looking at some of the initial demonstration stuff, and I think even Liz Rice was showing a demo early on about how changing what a packet is going to do at the driver at the time it hits that card, that NIC card, and being able to say, hold on, before I send it anywhere else, we're going to modify it or we're going to change it. We're going to dump it if it's not right. Making decisions at that low level like that without adding the overhead, that is security, right? If you can take bad packets or packet storms and things like that and fix that problem where they never go past the very first entry point, that's pretty huge, I would think.
Yeah, it is very huge, and that's what Liz and a bunch of people have been looking at it. And you sort of have, there's Inspector Gadget that has a lot of those things for Kubernetes where you can do that, so that you can view that as security. It's just that a lot of the security people I've worked with and know really well, they view that they sort of say, well, that's security, but what we mean by security is compliance. They go up the stack and say, what we're really interested in is all these larger things. How do I know you're really corresponding to HIPAA, P, you know, PII, and all those kind of concepts? So the problem is it doesn't answer that. So then the whole idea: do we need to build a framework that could plug into that? So you say, oh, well, these packets relate to the things you're talking about in terms of making sure we do compliance.
Right, right. I want to take a little side trip here because if we think about uh, DevOps, right? We're talking about security and performance that should be built into DevOps. Whenever I hear a story around security, like what we just talked about, anytime there can be a decision made around a security, don't do this with this packet, send it over here, drop this, send an alert. there's a performance use case right there. Okay, if this causes too much of an overhead or causes resources to be depleted at that point, make the decision, create a trigger, send an alert somewhere. So now we have the concept of DevSecOps, and I want to get your thoughts on that. Should DevSecOps even exist? Shouldn't security be integrated into DevOps?
I had a discussion about this with someone this morning because we were talking about DevSecOps, and I said, but it's why is it different than having that as part of DevOps or even platform engineering? Why do we need a unique system? You know, and he said, well, it's different. And I said, yeah, but all you're really proposing is that these 50 tools that you use on top of DevOps to get you to DevSecOps. It's no different. If I roll it all up, it's all part of platform engineering. So why do we think it's different?
Agree. And what I've been told is the reason why DevSecOps exists is that security was supposed to be a non-negotiable as part of delivery of the software in DevOps. It was not handled appropriately. The big boys came in and said, we're gonna make sure that you do that. So we will have our little sec dropped in the middle of that. Well, that made me mad because I'm not in security, I'm in performance. So why can't I have DevPerfOps and do the same thing? Because in my opinion, as I've seen over the last few years in DevOps teams firsthand, performance is not necessarily a non-negotiable, and things go out, and we still have outages, and we still have problems because it's not a non-negotiable. Any thoughts? So, if DevSecOps gets to exist, should something like DevPerfOps exist as well?
I've been reading your stuff lately, and I've been pondering that because, the performance issue doesn't get handled well. And since my background is really software engineering, in a fundamental way, that gets ignored no matter what. You see like, oh, well, we'll do testing, we'll look at this, we'll do chaos testing, which I think is better. But because of the way all software gets built, I would claim performance is like the last 1%. And we'll handle that later. Oh, by the way, the client needs it now. So as long as they can enter what they want, as long as it's just fast enough. And just fast enough is, a very indiscriminate term to use.
Mm-hmm. It's not a defined requirement at all. And here's the thing: it's not important until it is important. When it goes down because of unexpected load, and you're not making money every minute because of that, then all of a sudden it's important, but it's too late at that point. So how do we turn the ship around and say, look, I don't care if you don't call it DevPerfOps, and I don't care if DevSecOps. I think neither one of them should exist. But how do we make the DevOps native, people say, yes, we will do that? How do we change it?
Well, that to me is a complicated problem, but I think we can do it. I think part of it is that, you know, development has kind of ignored that thing, as I said. In my history, when we were writing code for switches, performance was vital. You couldn't just suddenly go, oh, well, oh, the switch is overloaded. Oh, well, just later, well, we drop a bunch of phone calls, and that's not super cool. But it's making it. People need to think about performance. They need to think about security. You know, just as everything else. There are all these non-functional requirements. They hit a lot of them, but the ones that look system oriented get ignored. That's how
Mhm.
I view it because that's a system thing. You know, I'm a software engineer. I know nothing about that. It's sort of like the whole Kubernetes problem. Fundamentally, the developer should use Kubernetes, but it's become so embedded in the DevOps team. Then when you give them a Kubernetes instance, developers like, what does this do? Why do I use it? Where did it come from? And then performance is also another one of those. Well, I have enough things to do. Why do I have to plug all these other things in?
Yeah, and I mean, I definitely don't want to be the one that holds up development and the pipeline, right? But I think there's got to be a way that we can do it that where it doesn't cause friction, but it still gets done. And I think it's a combination of them, the developers. When I say them, the developers understanding their scope around performance. They don't have to do everything around performance, but in their purview, take care of the performance. And we still need performance engineers. You can call them an SRE if you want to, but whoever handles the larger performance scope should be handling that too. And that way, if you get them both sides, right? But let me see if I can tie this back to eBPF. If we have eBPF programs embedded natively inside the kernel, and it's part of, say, a Kubernetes deployed application, Doesn't that sort of build in some shift left performance that can be there to set the alert to let people know early there's a problem? Do you think that will help get us there?
It will help because I view that as a day two operation. Fundamentally, you're going to manage and say, hey, I've got all these things built in. So we can look at it as a day two thing. It's not day zero, day one, we can use it. So we've got it in there, we have to use it, and it's important, and using it is vital. But you raise an interesting issue is that eBPF, even though it looks popular to you and I and other people, across the industry, it's still a little niche, tiny thing.
It's an infant right now, and part of
It,
that will stay that way as if it keeps staying complicated to most people. When you begin to lower the bar of entry, more people will do it, I believe. How long do you think it'll be before we take something that's really complex like that and do something to distill it down to where anybody can deploy it easily?
a couple years because I can give a simple example. I was talking to somebody who's a bright developer, and they go, "How should I use it?" Okay, this gets complicated. Do you want to use BCC and use it with Python? Do you want to the libBPF library? Do you want to use Go? Because there's so many ways to use it at that level. People, their eyes start closing because they're like, "What? Which way do you want to do it?" There's BPF trace, which you can just write a one-liner, and because there's so many. Hence, the various books out there that are so large and they're 900 pages. People look at those and go, "Oh, I can't use this." They're chapters on CPUs, they're chapters on performance, And I think that's for Netflix and everybody else who's used it, it's valuable. But if I'm writing, kind of an interesting like ticketing app, I'm like, I can't use this. I can't figure out what to do. I'm in JavaScript. How does it work? And then you can say, well, you could use Cilium. And they're like, well, how do I turn that on? And then you start, the level of introduction is high.
Yeah, I agree, and I think that's what has to change because people, in my opinion, most people are lazy to begin with. They look for the low hanging fruit. They're going to do what's easy, and if something's hard. There will be some people who do it, and they'll get a lot of ROI from that. But not everybody's going to want to go there. So I think it's an educational type thing, and I always look at people and say, "Well, this is hard." I'm like, "You're in IT. This is the area you wanted to be in." And sometimes things have to be complex. If the development is complex, don't think that the testing and the monitoring won't be complex. And the more intricate it is, the more of that testing and checking and verification you're going to need, right?
Yeah. And I think, part of it is because everything, uh, well, my naivete is basically people think, well, I can just run a search and find what I want. I'm like, not necessarily in this case,
I can ask
because,
Chat GPT.
yeah, I've done that. It gives me an answer I don't like.
It doesn't give you what you want. I know.
I know it like, well, that's because people think, the whole AI thing, if I just shove things in there, suddenly I'll have a complete whatever it is.
Mhm. Yeah,
Yeah.
I that would be a good experiment to get ChatGPT or Gemini or somebody, a co-pilot, to write an eBPF program. You might be surprised at what you might see. You probably have to tweak it, but I don't know. Could be an interesting experiment.
I haven't gone that far. You know what I mean? I got rid of Copilot because I started using it. And then I discovered then I would not do the appropriate thing. So I decided that, it's too much of a crutch. So I don't need it.
Yeah, sometimes you need less choices to force you to do things that will actually cause your creativity to kick in and do things the right way. I totally agree. So talk a little bit about like what you're doing now. You mentioned that you're writing a couple of books and you're getting involved with some stuff. Talk a little bit about where like how can people find out more about you and what you're working on?
I'll normally put it by LinkedIn. You know what I mean? I haven't put much about the books yet because they're in a stage, but I will start putting more of that out there. I
Okay.
just haven't I haven't done it. I've been lately doing more of those what's your answer in LinkedIn thing, contributing to stuff. And I occasionally write articles on TechStrong. I've done things on platform engineering, Kubernetes. I tend to use the TechStrong platform because I know those guys pretty well.
Awesome. Well, I'll make sure that I share your LinkedIn profile with my audience and we'll put some links in the show notes and everything and make sure we get the word out about you. I think more people do need to know what you're working on. I'm looking forward to seeing what you come up with here on this eBPF stuff. And when you get it working, maybe we'll have you back on and you can do a demo and show off what's going on with
I
it.
almost have a demo. I'm almost there. It's not where I want it to be. It still required like a little, magic to demo it. When I demoed it to the one person I knew, they're like, "Oh, you have to twiddle a lot of knobs." I said, "Yes, surprisingly, I do."
Well, when you get it working, we'll do a demo. We'll show it off. That'll be cool. Donald, thanks so much for being on the program today, and you're welcome back anytime. And we'll see you soon.
Thanks. Have a great day. I appreciate it.
So, as you heard, I like to get off on that little rabbit trail about DevPerfOps quite a bit lately, and Donald's been following that. I am really easy for you to give feedback to in case you wanted to. You can contact me several different ways, but the main way is just scan that QR code or check out LinkedIn, Twitter, Instagram. You can see my feed out there, smcjournal.com. Real easy to find, connect to, and follow. You can also send me an email to heyscott@smcjournal.com. Would love to hear from you. And if you haven't already and you like this content, could you subscribe to our YouTube channel? Hit that like button, and that really helps me understand if I am doing the right thing. It helps the algorithm, helps other people find me when they're interested in the topic of software engineering. So, thank you once again for watching. I'll see you on the next show. Until then, Scott Moore saying bye bye.